next session is about talking about the MVVM. So right next to me is Sergio is waiting for that. Hello, Sergio. How are you?
Hello. Hey. Thanks for having me. Hello.
Oh. So are you ready to start talking about the MVVM?
Yep, we're super ready.
Yeah, yes. I personally have the less less confident at using the MVVM because it seems to be kind of a higher learning curve for me. So, but I'm really interested in watching your session. Okay, it's your
That's
turn
awesome.
now.
All right, let's do this. So, hey everyone, thanks for joining me. So, I'm Sergio Pedri, and I'm a software engineer here at Microsoft. I work in the Microsoft Store client team, and I also lead the .NET Community Toolkit. Now, today I would like to showcase some of the new features and performance improvements that we did in the upcoming 8.1 release of the .NET Community Toolkit. And specifically, I would like to focus on the performance improvements around the MVVM Toolkit source generators. So before diving into the MVVM Toolkit in particular, I want to also give you a small recap of what the .NET Community Toolkit is actually about. So the .NET Community Toolkit is a set of libraries and helpers for .NET developers with no platform-specific dependency that is also published by Microsoft and part of the .NET Foundation. So for more info on this project and all the other toolkits that are part of the Community Toolkit organization, I highly recommend watching Michael Hawke's presentation for .NET Conf, where he goes into more details about the whole history of the Community Toolkit org and all the various components that it includes. So for today, as I mentioned, I really want to just focus on the MVVM Toolkit. So for those of you not familiar with it already, the MVVM Toolkit is a modern, fast, and modular MVVM library that's part of the .NET Community Toolkit. It's also the MVVM library that we use in some inbox apps that ship with Windows, such as the Microsoft Store. And it's also the official successor to MVVM Lite. In fact, we closely worked with Laurent Bougnon, who is the original developer of MVVM Lite, to ensure that existing MVVM Lite users had an easy-to-follow migration path to move to the MVVM Toolkit, which is now the recommended successor. Now, the MVVM Toolkit is built around 4 core principles. So first, it multi-targets .NET 6 and .NET Standard 2.0, meaning that it can be used by all developers, even on older runtimes and frameworks, while at the same time also being able to offer additional performance improvements when running on new runtimes where more optimized APIs are available. So if that's the case, we will just automatically pick them up and give you the extra performance. Next, it's also simple to pick up and use and a la carte. And what we mean by that is that it doesn't force you to organize your code base in any specific way in order to use it. But instead, you can just pick up the individual components that you want from it. So for instance, you might want to use the observable object type for your viewmodels or the relay command type for your MVVM commands. And then you can just use all of these components within your existing code base however you want. And then lastly, it's also meant to be a reference implementation for a lot of interfaces that exist in the BCL, that would be the base class library of .NET, that's not opinionated nor tied to any specific UI framework. And so, for instance, we have the observable object type and the relay command types in the MVVM Toolkit, which are the reference implementations that we offer for the iNotify property changed and iCommand interfaces from the BCL, respectively. Now, before going into all the details about the performance improvements of the generators in the MVVM Toolkit, I actually want to show you what they look like in action. And so here on the left, you can see an example of a very simple view model that's using the MVVM Toolkit, but without the source generators. So you can see we have an observable property, this name property, that's using the setProperty helper method that's exposed by the base observable object type. And then we also have a command, this initialize command, which is using the async relay command type. Now, if you work with MVVM, this should look very familiar to you. And this code works just fine, and there's nothing inherently wrong with it. But you can see that there's quite a lot of boilerplate code involved. There's a lot of repetition, and it would just be better if it wasn't the case. And so to fix that, you can see here on the right what the same code looks like, but after refactoring the view model to leverage the new source generators in the MVVM Toolkit. And so you can see how the property is now just a field that's annotated with the observable property attribute. And then the command is now just a method that's annotated with the relay command attribute. And so you can see how from just this, the generator will just kick in automatically, and it will generate all of that same boilerplate code for you behind the scenes so that your code can actually be much simpler. And so you might ask, how do all of these source generators actually work? And so to answer that, here's a flowchart that shows how the Roslyn compiler actually handles all of these various source generators. So what happens is, every single time the compilation is updated, Roslyn will run all of these source generators, will allow them to analyze code and generate new code, and then will add all of these new generated source files back into the compilation, which will then continue by combining both all of the original source files, which you wrote, with all the generated source files. And this is what allows the MVVM Toolkit to support all of the features such as the observer properties, the relay commands, and much more. And there's also one crucial aspect to this. So because the compilation is updated constantly, every single time you even type a single character, this means that IntelliSense can also show suggestions for members that are generated on the fly, like literally while you're typing, which is pretty cool. But this also means that generators have to be really, really fast. Specifically, they have to run in less than 10 milliseconds, because otherwise the whole IDE will just become sluggish, slower, and the developer experience as a whole will suffer. And so this is why performance improvements is extremely important for source generators. And so for that, I actually want to go over some of the new performance improvements that we did in this new release. So the first one that I want to start with is the fact that we're now using the for attribute with metadata name API from Roslyn, which you can see being used here. This is the relay command source generator. So to explain how this works, think about how the relay command feature is actually implemented. So you have a method, you add the relay command attribute, and then you want the generator to just create a command for this method. So what this means is that the generator has to look for all of the method declarations in your project. It has to go through all of the attributes over these methods. Then it has to check whether any of them matches the relay command attribute. And then if that's the case, then it knows that this method has to generate a command, and then it can go ahead, analyze the method, and then generate the command. And that works just fine. That's what we used to do up until now. But there's actually one downside to this. So basically, this means that the generator is asking Roslyn to load all of the symbols for this method, where the symbols are the metadata representation in Roslyn type system of a given entity, in this case of a method. So it's doing that for all of these methods just to check whether or not they have to generate a command, which is actually very expensive. And the reason for this is that Roslyn would normally just create all of these symbols lazily while running source generators, but instead we were forcing it to generate all of these eagerly just so we could check whether or not a method needed to generate a command. And so this new API actually solves this, because it now gives the compiler a way to only execute the generator when it already knows that a given target, in this case we are targeting all method declaration syntax nodes, has a given attribute that we're looking for. In this case, we're looking for relay command attributes. And so this greatly reduces the number of symbols that we actually ask Roslyn to create. And in turn, this makes the generator like an order of magnitude faster than before. So this was one of the most crucial optimizations that we did in this new release. Now, next, I want to talk about the diagnostics that the source generators emit. So one very important component of all of our generators is that they are able to also emit a lot of diagnostics whenever you use any of the features incorrectly. And this is really, really important, especially for beginners, so that if they are trying to use the generators wrong, we can just let them know that that's the case. So for instance, if you have a method and you ask a command to be generated for it, but the method has an invalid signature, we will emit some diagnostics telling you exactly what's wrong and how to fix it. Now, this is pretty useful, but it also adds quite a lot of overhead to all of these various generators. And that's also where, even when they're not actually needed, so even if your code is actually fine and doesn't need any diagnostics. So to fix this, we moved most of our diagnostics, almost all of them, to diagnostics analyzers, like this one that you can see here. So what a diagnostic analyzer is it's essentially a Roslyn plugin that can analyze code and it can emit diagnostics for this code. And crucially, all of these analyzers can run out of process and asynchronously, meaning that IntelliSense doesn't actually have to wait for them to run while you're typing. And this, again, greatly improves the performance of the generators, especially when working on very large solutions. Now, the last performance improvement that I want to cover is how we improved our source generator model, incremental models. So one crucial aspect of the generators is the fact that they're incremental, which means that while running, they build a model representing all of the info on the code that they've analyzed, and then they can compare these models across compilations. And so this allows them to detect whenever an actual change has occurred, and so they can go ahead and generate new code. Now, this is extremely important, especially when working on large solutions. So imagine you changed a command in a project that has maybe 1,000 commands or more. Now, you wouldn't want all of those 1,000 commands to be regenerated all of the time just because you changed one of them. You would just want the one that you actually modified to cause new code to be generated. And so this is where incrementality is actually a key component. Now, using records is actually a pretty common pattern for these incremental models because they have built-in value equality, which is perfect. And that works just fine, except when you have a record like this command info here, which is our record type for the relay command generator, that has some properties that need to contain a sequence of elements. So for instance, we were using immutable array properties, but the issue is that immutable arrays don't have value equality semantics, meaning that if you have two different immutable arrays, even if they contain the same elements, they will not actually compare to be the same, which would break incrementality. And so we would normally have to manually spot all of these cases, manually write a custom comparer, and then inject that onto the model, which would add overhead and make the whole thing a lot more complicated. And so to fix this, we added this new equatable array type, which is basically just a thin wrapper around an immutable array. But the difference is that it has built-in value equality semantics. And so you can see how we're now using it everywhere in all of our incremental models, like here in this command info type. And this makes sure that all of these models are properly equatable, that we don't accidentally break the incrementality without noticing just because we forgot to add a custom comparer. And at the same time, it also helps make the whole thing even more efficient. Now, I actually want to move on to new features that you can use directly. And so the biggest one in 8.1 is the fact that we added support for custom attributes for generated properties. This means that you can now use the property target in an attribute list on a field that's annotated with observable property, and this will cause the generator to forward those attributes over to the generated property. So for instance, you can see here we have this name field that's annotated with observable property. We have a couple of JSON attributes that are using the property target, and you can see them being forwarded over to the generated property. Now, this was actually one of the most requested features, so we're happy to say that it's finally available. And we've gone through several different iterations of this feature, and eventually we landed on just reusing the existing property syntax from C#. And we like this because it basically did two things. So first, due to the fact that it's using a built-in C# keyword, it makes the whole thing feel more integrated with the language. And second, it also allows you to use attributes that maybe are only allowed on properties, which you normally wouldn't be able to use on a field at all. But turns out, if you use the property target, Roslyn will just move aside and let you still use those attributes on a field, even if they're only allowed on a property. And then we can go in and actually forward those. And so to showcase how all of these features come together, let me actually move over to Visual Studio. And I want to show you a very simple MAUI application that I built that showcases both the generators and the new property target. So first, let me actually just run that so I can show you what we have. So this is just a slightly modified version of the default MAUI template. So you can see here we have an entry where I can just type my name, and you can see the name gets reflected here. I have a button that I can click, and every time I click it, there's a counter that's incremented, and the message is also updated to reflect that. And then finally, I also have a slider, which I can move, and then you can see the value being reflected here. All right. Now, if you go and look at the view model to see what we have, you can see we have first a bunch of observable properties, which are manually implemented. So each is using set property and then also notifying a dependent property. So for instance, we have name, that's also notifying the greeting message property. Then we have those message properties that are displayed in those text boxes. And then finally, we have a bunch of commands. We have the increment counter command, and then we have a couple of save and restore buttons, which we'll talk about later. So again, you can see how all this code is pretty straightforward, but it's pretty verbose, and there's a lot of boilerplate code. So in this demo, I want to do two things. So first, I want to refactor this view model to leverage the source generators to make all of this thing much more compact. And then I also want to showcase how we can use the property target for custom attributes, in this case, to implement JSON serialization for this view model and implement the ability to save and restore a session in this application. So let's start from the first step. Let's make this view model use the source generators. So for this, the first thing I'm going to do is I will make this type partial. Whoops. And this will allow the generator to generate other partial declarations of this class with all the generated members. So first, let's start with the observable properties. So what I want to do is I want to just take this field. I will add observable property on it. And then since this field this property also needs to notify this other property, greeting message, I will use the notify property changed for attribute, still from the MVVM Toolkit, and I will tell it to also notify the greeting message property, right? And then I can just delete this. Now, if we want to double check the generated code for this, we can easily do so by just expanding the dependencies node here in the Solution Explorer. We go into Analyzers, Community Toolkit.mvvm. We find the observer property generator, and we can see that there's a new file. And sure enough, here it is, the new name property that's doing exactly what you would expect. And at the end, you can see how it's also raising a notification for the greeting message dependent property as we asked. All right, this is looking good. Then we can do exactly the same for the other two properties as well. So let me do that for amount. And in this case, I will notify amount message. You can delete this one. And then I will also do exactly the same for counter. Once again, I will change the dependent property to notify counter message. Right, this is looking much better already. Now let's talk about the commands. So for this, what I want to do is first I will just delete these commands entirely because they will just be generated. Then I can also delete the constructor because there's no commands to set anyway. And then I can just add the relay command attribute over this method. So let me just do that. So we'll do that here. And then I will also do exactly the same for the other two methods below. And now, once again, we can check the generated code. So for that, we want to expand the relay command generator node. And then you can see there's 3 files, 1 per command. And so for instance, if we expand the first one, you can see that now we have the auto-generated increment counter command that's using the relay command type, which is here, to wrap our increment counter method. All right, this is looking good. So now we can just run the app again just to double check that we didn't break anything. And you can see how the whole view model is already much smaller than before. It's like half the code, and it's doing exactly the same with the generator just taking care of creating all of this boilerplate code for us. So here's the app, and we can just double check. I will type my name. You can see the text box reflecting the changes. I can click the button, slide the slider. All right, this is all looking good. Now, the next thing I want to do is I want to also implement JSON serialization for this model. So let's start from these properties. So let's say I also want to customize how the JSON serialization works here. So maybe for this name field, I want to make the property required, and I also want to call it username. So let me just do property, and then I will add a JSON required attribute. And then I can also add a property, and we said we want to call this username instead. So I will add JSON property name, and I will call this username. Now, once again, we can double check the generated code. We can move over here. And if we expand this file, you can see that here's the generated name property. And you can see the 2 attributes that we asked for that are correctly forwarded over to the generated member exactly as we wanted. All right, this is perfect. Now, let's also do the same for the other 2. So let's say in this case, I want the amount property to be called slider amount. And let's say I also want to allow reading values from a string for extra reliability. Why not? So I will say JSON number handling, and I will say allow reading from string. Right? And then I can also do exactly the same for the other property here. And I will call this button counter. Right? Now, the one thing that's left to do is to actually implement these 2 commands to save the JSON state to a file and then load it back. Now, since we're going to do some file I/O, I want these 2 commands to be asynchronous. So why don't we just try to do exactly that? So let me just change the name of these methods to add the async suffix here. And I will also change those to be async task returning methods, right? And now you can see how we could do that and the generator didn't complain. And in fact, if we go back to the relay command generator, you can see that it has automatically adapted to this change, and now it's using the async relay command type and the async relay command to wrap the asynchronous method. So this is because the generator automatically supports both synchronous and asynchronous commands. And in this case, whenever it wraps an asynchronous commands, it also gives you additional benefits such as built-in support for cancellation, and also it gives you the ability to easily track whether or not a given command is running. So for instance, you can have a progress string that just binds to the is running property of a command. So you will no longer have to ever manually keep track of is busy or is running property to show some loading ring. You can just use an async command and just rely on that to handle all of this for you. All right, so what I want to do here is first I will get the path of the file to save. So for that, let me just do string path, and I will say path combine, and I want to get the directory name of the current location. So assembly, get executing assembly.location, and I will call the file state.json. Then I will open a file stream to this file. So I will say using file stream. I will open a file stream to this path using file mode create. Then I will serialize the state to this file. So I will just say await JSON serializer, serialize async. I will pass the file stream. I will pass this. And then I also want some options. So in this case, I will say JSON options. And I want to ignore read-only properties. So this is so that we don't actually serialize the commands nor the message properties, because those are not actually carrying any state. We just want to serialize the username, the counter, and the slider amount. Right? This is looking good. And then we can just do exactly the same here, just in the reverse direction. So I will copy this. I will open a file stream, but this time in open mode. Then I will deserialize the state. So I will just say state equals await JSON serializer, serialize async. I need a main page viewmodel back, and I will pass the file stream. And now that we have deserialized the file, then we can just read back the values and assign them to the current instance. So I can say name equals state.name. I can say amount equals state.amount, and then finally counter equals state. I cannot type today. Whoops. State.counter. All right. Now I can deploy the app again, and hopefully, if I got everything right, we now should be able to also save the current session and restore it afterwards. So here's the app. And so the first thing I will do once it pops up, it should be any second now, here it is, I will type my name. I can click on the button a few times, and I can slide to any random number. Then I can save the state. And now to show you how this works, I can just close the app and start it again. I have no idea what happened. And if I click on restore state, there it is. You can see how the whole session has been restored, and now all the values are back, and we serialize the whole viewmodel state and restore them afterwards. Now, this was just a very quick demo just to showcase how you can combine both the source generators to make your viewmodels much less verbose, and also leverage the new property target support for injecting any custom attribute that you want over the generated property, so that whenever you need any of those custom attributes, you no longer have to fall back to using manual properties, but you can still stick to observer properties, which are auto-generated, while also leveraging the new support for all these custom attributes. Thank you.
Thanks, Sergio. It's really good session. I'm pretty sure everyone in this session, like me, has got more idea how MVVM can be easier than before using this MVVM toolkit. I have a question from YouTube channel. Jose asks that this MVVM toolkit, does this MVVM toolkit use the new keyword called file? If say yes, and yeah. Are you able to answer that?
I'm not sure I understand what you're referring to, I'm afraid.
Oh, okay. So probably, yeah.
Like, feel free to just leave a question either on our GitHub repo at github.com/communitytoolkit/.net, or just open a discussion so I can answer that and follow up with you. So.
Sure. And also, there is another question from the Twitch. Says that are you referring to the original MVVM toolkit, or you are referring to a sort of new different one?
Not sure what you mean by original MVVM toolkit. So this is a project that we started a couple of years ago. It started out in the Windows Community Toolkit, so maybe that's the one that you're referring to. And then we moved that.
So, yeah.
Right, and then so that's the same project. It's just that we moved that over to the new .NET Community Toolkit. So we basically decoupled all of the .NET libraries that used to be in the Windows Community Toolkit. So that would be the MVVM Toolkit, the high performance package, the diagnostics package, and then another common helper with a bunch of additional APIs. We moved all of those over to what is now an independent and separate toolkit, which is just for .NET. So now that can version independently with the Windows Community Toolkit.
Right, I see. So hopefully those answers from Sergio will answer your questions from audiences. And yeah, thanks Sergio again.
Yep, thanks for having me. Have a great rest of .NET Conf.